Now, related to spectrum management or spectrum planning, I will mainly highlight the most important ones and just give a few words about the others. This is not most important, but this could be interesting to know when checking. Let me check the right project. Yeah, the Geneva 06 conformity. So we have here French stations, and we would like to check the conformity of a given allotment located here in UK, and the the allotment information is provided in the Geo06 calc tool. This is an ITU tool that can export in a text file information about the frequency, the location of the test points, and so on. And this is a format that has been added. So if we go to Spectrum, ITU, Geneva 06 conformity. So we have here a text file. I can show you here. If I open it, this is how it looks like. So we have azimuth. This is the test point that we have, where the maximum field strength that should not be exceeded, and so on. This feature is not new. What is new is the fact that we can cope with the Geo06 calc format. And the calculations, of course, will be the same. So we check on each test point what's happening. And we see if we have a conformity or not. Not okay means that we have a problem on some test points. Okay, and you can see in the list what's happening on each test point. Okay, this is mainly for broadcast. Okay, broadcast coordination. The idea is to check in a given network if it's possible to reduce the power of the existing network without losing too much coverage and without being too much interfered. So if we go back to other sample, that one, so we have here a given network. It can be of any kind. And the feature is located here, coverage, network planning, power reduction. Power reduction C2I means that we don't only check the coverage, but also if we are also experiencing more interference due to the power reduction. We can check only what is the covered area lost when we reduce the power, and also if the interference is higher or not. But we can also check population, and in that case we can specify we don't want to lose more than 5% of population covered and not interfered. Okay, we just briefly, without population, it would be faster. Okay, so there is an option to either, if I answer no, just check the possible options we have, or directly modify station power and modify coverage as well. I will answer no, it would be faster. So the population is not checked, but only the the area covered. We have allowed a loss of 10%, as far as I remember, of coverage. So this is for station here, station number 1, for example. The current usable coverage means coverage not interfered with the current power. But if we reduce the power of 2 dB on that station, then we will cover an area that is not interfered with the less than 10 dB loss compared to that. So this is a way to spare power and then money for the operators to radiate less power without losing too much coverage or too much population coverage. ICS Manager NoDB, nothing specific added to ICS Manager, just to mention that we have moved access to ICS Manager NoDB and tools extensions, ICS Manager NoDB. ICS Manager NoDB is provided with HTZ communication or warfare. This is a reminder. This is a tool that is not embedding a database, but just offering a way to be connected to external databases, either ITU, Verific or ITU, or satellite database, FCC database, and so on. And the idea is to open a link to the external databases and import either stations or satellites from the manager tool to HTZ. So network analysis side-by-side simultaneous coverage. The idea of that feature is it's a bit an advanced feature of network design. The idea is to say what could happen if we switch off a given station in a network, but without losing overlap. We know that we will lose coverage, but we will also lose overlap. And if a minimum overlap is required in a network, we need to check what's happening if we lose or if we remove a given station, if we can keep or not the global overlapping level in the network. This is the idea. And this is made side by side. What's happening if we remove that particular station? What is the current overlap we have, and what is the new overlap without that station? Is it okay or not to remove it? So this is coverage network analysis and side-by-side simultaneous server. We have different options here, just a report of the overlapping levels that is experienced by each station, or optimizing the overlapping level with, for example, an option to turn off the stations. So I will require an overlapping level in that example of at least 2, meaning that I need to have at least 2 stations received as much as possible everywhere in the network. So we have a current overlapping level, and we will check what could happen if some stations are turned off. So we have a report here. Okay, sorry. Some stations that were deactivated before. Okay, can just look at the report here. So we have like this. On the first line, what is the current situation? And on the last line, what is the new situation when we have removed some stations? Most of them have not been removed except that one. Removed means deactivated only. So how to read the report? So for the first station, we have 3 figures here. One is considering that we have the rest of the network activated, the total area net with an overlapping of 2, with an overlapping greater than 2 and lower than 2. As soon as the overlapping lower than 2, it means that this is already what where we don't have what is expected. We should not modify that value. We should not lose more areas where we have not the expected overlapping. So here we will lose. And for that one, no change, or no change. So if we remove that one, we will still get the same overlapping, global overlapping level. And this is the situation here. So we keep the minimum overlapping level greater than 78%. Okay. CCTV coverage. This is a new feature here. So we can check that this is a site coverage for CCTV cameras, but this is not just visibility, but also we consider the aperture of the camera in H and V plane. Even if you have visibility, you put a camera in an open space, you won't be able to have a look at what's happening 360 degrees around, but just in a given range of angles. So this is a way to check the CCTV coverage. I can show you coverage on CCTV. So we can check the CCTV coverage either from the point I have clicked, or this is that option here. In that case, we need to specify parameters, or if the sources that are used, or the cameras, are already on station locations. Okay, so we have here what can be seen within a given range of angles that were specified before. So this is what can be seen from that camera here, for example.